All right, so today we're going to be talking about similarity and similar figures. Before we get to talking about that, our last unit was all about congruence. So this is actually the second part of the last unit. This unit is called ConSim for congruent and similarity. So before we talk about similarity, let's talk about congruent. What does it mean to be congruent? So same size, same shape. Do y'all agree? Right? And that's what that symbol means, congruent. What does equal mean? Same number, remember? And whenever we're talking about same number, I'm going to say size because size is a number. So what does just the squiggly mean? Same shape. That is what similarity means. If two things are similar, are they congruent? Are they exactly the same? No. But they have the same shape, they are just not the same size. So for similar figures, if two figures are similar, then they are the same shape, different size. In the real world, meaning outside of this classroom, where are similar figures used?
Everywhere.
Has anybody ever played with a Hot Wheel? Do y'all agree a car Hot Wheel is similar to the cars that they are? They're just different sizes. Yep. Where else? What else in the world do you deal with every day that has similar? Legos. Don't you agree they have different size Legos? My daughters are little, so they deal with it. Shoes. Shoes are a perfect example of similar figures because aren't they the exact same shape? They're just different sizes. What about shirts? Right? Aren't your shirts the same size, or not same size, same shape? They're just different sizes. Glasses. What else? Pants. Most clothes and hats. If you got a big head, you wear a big hat. A bigger hat than people with little heads. Christmas trees. I like that. So, don't you agree companies use similarity all the time to make different things? Big thing is in construction. Think about building buildings. What do a lot of companies do before they build the building? They build a base, they make a model or a blueprint. Both the models, a lot of companies nowadays do 3D models on the computer, but both the models, are they the exact same size as what the building is going to be? No, they scale it down. So that is where all of this is connected and what it's used for. Something I need you to know is that the angles, let me do an example before I do that. What shape is this? Be more specific. Do y'all agree this is an equilateral triangle? What do we know about an equilateral triangle? Inside an equilateral triangle. Each angle equals 60. Do y'all agree with that? What about this shape right here? Same thing. But it's bigger. Can the angles be the same? Even though it's bigger? Yes. So on similar figures, your angles are congruent. It doesn't matter that the shape is bigger. My angles stay the same. But what about my sides? Are my sides the same? No. For sides, we're going to use this word. Can everybody say proportional? Everybody say proportional. Thank you, Maddox. What does proportional mean? What does proportional mean?
It's open. Automatic.
Same amount each side. So, has anybody ever bought a shirt and it was too small? So you went a size up and it got wider, but it was too short. Has that ever happened to anybody? Right? So they did not proportionally make the shirt bigger. They just made the shirt wider. It's really annoying when that happens. All right, I want you to look at these triangles here. Which triangle is proportional to my original equilateral? This is proportional?
Oh, no, the one on the right.
Why?
Because it's the same angle.
The same angles, and what does it do to all three sides?
Or is that different?
They're all the same.
But what does it do to each of them?
It scales it.
Scaled it by how much? It multiplies by 4. Does it multiply all of them by 4?
Yes.
So that makes it proportional because it did it to all of them. This one, it multiplies by 4, don't you agree? But does it do all of them? So these two right here, these are non-proportional. Because it doesn't do all three sides, it only does 2 of them. All right, so the corresponding sides, in order for them to be similar, all the sides have to be proportional. All right? And then last but not least, what did I tell you the symbol was for similar? Everybody please draw a little squiggly. It's called a tilde. A tilde. I call it a squiggly, but it's called a tilde. All right, open up your notes, please. Annie, with me? Is she with me? All right. Now, new word we are going to learn today is scale factor. A scale factor is a ratio, meaning you divide, that will transform a pre-image to an image. A pre-image is your old image, and your new image, or your image is your new image. So we are going to be dividing our old and our new to find scale factor. By the way, you're going to see me write scale factor as SF. Scale factor, to find it, you are going to divide your new divided by your old. Or your second divided by the first. Or your image divided by your pre-image. Please write all of these down. All right, let's go look at that lotus again. A lotus is 64 inches tall. A Hot Wheel is 1 inch tall. So in order to find the scale factor, I do my new over my old. So I'm going to do 1 over 64. That gives me a scale factor of 1/64. And that's how they create it. What? Okay, so that's a good question. How do you know? So you are always, in this one, originally, the old is going to be the car because that's the one made first. But on your paper, you are going to be looking at where are the arrows. So look at the bottom. We're going to do the bottom part of your paper first. Where are my arrows is going to tell me which one's old and which one's new. So like for this first one, what is old? What's new? 4, 7. Can everybody write old and new? So to find the scale factor, you do new over old. What am I going to divide here? What's my new? No, new. So I'm just going to do 12 first. Over, what's my old? 4. What is 12 over 4? 3. That is your scale factor. That is all you have to do. Could you have done 21 over 7? What's 21 over 7? You would have gotten the same answer. So it doesn't matter. If you ever have a point, it doesn't matter which one you do. Let's look at my hearts. How do I know which one's old, which one's new? Old is which one? Jordan, focus. Can y'all make this arrow a little bit more obvious because it's kind of hard to see? This is old, this is new. Because the arrow points at the new one. So then to find scale factor, you're doing new over old. What's my new value? -8. What's my old value? And what is -8 divided by -2? A negative divided by a negative is a, and 8 divided by 2 is 4 is my scale factor. Y'all had already figured it out, but on this one, what was the scale factor? Times 4. Because what's 12 divided by 3? 4. Does everybody have this written down? What about on number 3? Which one is old? Which one is new? 7 is old. Can y'all make that arrow bigger again? 2 is new. So again, you're going to do new over old. So what am I going to do? 2 divided by 7. What is 2 divided by 7? Everybody please look up. Look up. Pick your heads up. Pick your heads up. Look up. When I divide 2 over 7, what do I get? I get this ugly decimal. Do I want you to give me an ugly decimal? No. Do I want you to round this ugly decimal? No. Look up at my board. What do I want you to do?
Round.
I just said no.
Keep it size.
Just give me the fraction. Hit the little fraction button right next to it. What's my answer? Just leave it 2 over 7. Now, it's not always going to be the same number because it might reduce. So make sure you put it in Desmos. Last one we're going to do together. How do I find this scale factor? Oh, real quick. I know it has it, but what if it didn't have an arrow? Do you see how it has this saying? Your old always comes first, then your new. If it has a saying, it's old and new. This one does have an arrow though, so we know old and new. If you have a similarity statement, you can still do your chart. Remember before the break we did our charts? What do we know about the angles? What did we say on the front about the angles? They're going to be the same. So I know it's really hard to see. What does that say? Does that say 50? I think that says 50. So if angle D is 50,
30.
what? It says 30?
Looks like a 30.
Let me see. Hold on. I think it's on here. It's 50. If angle D is 50, what goes with angle D? What would angle T be? 50. They're the same. So that's going to help you with your Schoology assignment. Just remember that. All right. I need to find the scale factor, so I'm doing new over old. What's my new value? 10. If I'm using that as 10, what am I going to use for my old? 18 or 12? I have to use 12 because KS goes with MH. What is 10 divided by 12? Do I want this ugly decimal? Click it. What do I get? 5/6 is my answer. And that is how you find scale factor. Okay? Now, what do you notice about my scale factors? We skipped a whole section. We're going to fill it in now real quick. What do we notice about these scale factors? Look at your paper. Look at example 1 and 2 versus 3 and 4. What do you notice? Different numbers. What are the top ones? Whole numbers. What are the bottom ones? Fractions. And what do you notice about your pictures? If it's a whole number, what's happening? It's getting bigger. And if it's a fraction less than 1, it's getting smaller. So if your scale factor is greater than 1, what happens? Instead of bigger, I'm going to write an enlargement happens. If it's greater than 1, an enlargement happens. What happens if your scale factor is less than 1? I'm cool with the word shrink or reduces or something like that. What's going to happen if your scale factor equals 1? It stays the same, which means they would be congruent. There is a special case. A scale factor can be negative. We're going to deal with this more after Christmas break. But I just want you to write it down. If a scale factor is negative, it will rotate 180 degrees. All right, you have 15 minutes left in class. What I would like you to do is around the room there is glue. Please add in page 31 and glue this in. If you do not have glue at your desk, look on the floor. I see some on the floor. Add this to page 31. It's similar figures. If you have glue and the person next to you doesn't, please use it and then hand it over. And then there's an assignment in Schoology for you to do. 12-2. That's what you're doing. Bye.